For today's Makerspace project, we'll be building an inchworm using littleBits. You're going to need the battery, the P1 power bit, and the power cable that connects the two. In addition to that, you'll need the 011 servo bit, and finally the I16 pulse bit. To begin, you need a piece of cardboard measuring at least 11 to 12 inches wide, as we'll be cutting it, in this case, 12 inches wide by 3 inches high. Now, when using any blade, especially an X-Acto knife, use extreme caution. These blades are super sharp. They work well, but they're also very dangerous if used incorrectly. You also could probably use these scissors, which may be safer in a classroom environment. In this case, we just used an old box. You can really use any type of cardboard. We've experimented with different variations of thickness of cardboard, and neither one really works better than the other. Okay, at this point you have a completed body of the inchworm. Again, it's measuring 3 inches high by 12 inches wide. You want to make sure you bend it in the middle, give it a good nice crease so the inchworm can move freely. Next, we're going to be cutting the feet for the inchworm. In real life, I don't know if inchworm have feet, but in this situation they will. So they're going to be measuring 2 inches wide by the height of the body. And they're going to be identical on the left and the right side. You can do one of two ways. You can measure them and cut them each, or the way we're going to do it is we're going to measure and cut the first leg, the first foot, and then put it on top of the right side of the body. So we have identical dimensions of the feet. Again, always be careful with that X-Acto knife. Okay, so the feet are in place. The next step will be to secure them with shipping tape or any kind of tape that you desire. I know shipping tape is about the same width of our body, so it worked really well, and it's super strong as well. So we're going to be taping the right and the left side on the top, and then we'll be flipping the body over and taping the back side. Now, one other option you can do, and we've tried this as well, is not cutting the feet, and actually just bend the left and right foot, at the 2-inch mark and put a nice crease in it. But through some experiments, it actually turns out it's got more maneuverability and it moves a lot faster actually when the feet are cut, because it's a nice solid crease versus trying to bend your cardboard. And the great thing about this project is there's a lot of different steps involved, and there's a lot of ways to improve your inchworm. So especially if you want to have competitions or challenges between other people, you can kind of find ways to soup up and make your inchworm faster. So now we have the body complete with the left and the right foot attached. We're going to flip it over to the back side. And now we're going to reinforce the body with bamboo skewers. They were actually probably the best used in this application, just because they have a very thin diameter. You could also try to find some dowel rod at a craft store or home improvement store. But anything you want to try to reinforce the body. We've done it once without the reinforcements, and it was a little thinner cardboard at the time, and it really does bend the body. The servo is actually pretty powerful, and it will actually bend your inchworm body. So these these supports or these reinforcements really aren't just for vanity, but they really do help keep the strength of the inchworm up, especially if you're going to be using it for a while. So we're going to be putting identical reinforcements on the left and the right. Make sure you leave enough gap in the middle, because that's where the servo is going to be. We'll be going next. We'll be cutting out a hole, or actually a rectangle, for the servo. So make sure your reinforcements are kind of maximized on the top and the bottom of the Inchworm body. Probably could also use hot glue in this situation. Feel free to experiment with different applications or different materials when building this project. Okay, so now we have the body with the 2 feet and the 4 reinforcements. So next we're going to be mounting the servo. It's about 1 inch wide by 3 inches long. Will be the final opening. But the goal is you want to have your servo be able to move freely. So as you'll see here, this rectangle in the opening was actually cut a little small in the beginning, and we're going to have to enlarge it once we place the servo. Probably would have been best to place the servo in its spot and draw out the diameter of the opening. So as you can see, it does kind of hit the left side of that opening. Kind of want it, in the center of that opening, with some clearance on the upper and lower side of the servo. So we're just kind of opening it up a little bit more, giving it more clearance there. Okay, now the opening is complete. So we're going to go ahead and mount the servo. Tried a couple different ways. We've done double-sided tape. It did work okay, but I also, since these bits are reusable, I don't like to put things like glue it or double-sided tape that might stick permanently to the little bit. So we found that zip ties work really well. Super strong. They keep the servo from moving on all the different axes. And you can just clip them off when you're done with the project to reuse the bit. So here's a smaller wire tie, or zip tie. And then later we'll be using a little larger zip tie. So you want to have probably 2 different sizes, or a range of sizes. Now the servo is being secured in place. You want to make sure it's really tight because, as I stated before, the servo is pretty powerful and it will try to wiggle on all the different axes. So you want to make sure it's really cinched down tight. And then go ahead and just cut off the excess, because you don't want that to get in the way of the body when it's moving. So as you can see, the servo is right in the middle of the opening. There's plenty of clearance on the left, right, top, and bottom. Now we're going to be cutting the traction triangles to the Inchworm. Really, because they do help grip, as you'll see later on in the demonstration. Now, when you're cutting these traction triangles, you want to have them going in the same direction, and that's for a reason. If you have one triangle going one way and the other side of the Inchworm going the opposite way, it actually won't move, because these triangles are designed to slide and then grip, slide and grip. So in this situation, the side where the servo's at, that's going to be our back side, or I guess the rear end of the Inchworm. Feel free to fast forward this part. I did want to show the entire process of cutting the triangles, but if you get the concept here, you can move a little ahead. We're going to do the triangles in this direction, and then on the other side in the same direction. Then once they're cut, we found that the bamboo skewers, to kind of pop them out, work really well, because you want to keep the foot as not bent as possible, keep it intact. So you really want to be delicate with that little foot and just pop out the traction triangles. And then once that's complete, you can move to the other side. So as I said before, the right side where the servo's at, that's going to be the back side. And now we're going to be cutting in the same direction, the front of the inchworm. Okay, now that the front traction triangles are cut out, we're going to do the same process. Just use something to pop out the triangles so they're bent at a small degree angle, so they can at least grip on the bottom side. Okay, now we have the completed body with the 2 feet, the traction triangles, and the servo mounted to the body. Next, we're going to be putting weights and counterweights on both sides of the feet. To secure them, we're going to use double-sided tape. Now once the tape's in place, we use a battery on the front. It's got just enough weight to hold down the feet, and it works really well with the 9-volt battery on the back side. So you want to make sure they're kind of dead middle of each of the feet. So next we're going to be attaching the P1 power bit to the power cable, which goes to the 9-volt. And attached to the P1 power bit is the I16 pulse bit. And then you also want to put the 011 servo next to the pulse bit. And what we're doing here is popping holes out of the body so you can secure the bits and the power cable to the body. We're using zip ties as well. Now when you zip down the bit assembly, don't cinch it down or tighten it down all the way, because we do need it in place, but we need to move it out of the way for the next step. As you can tell, it is kind of loose right now, and that's on purpose. The next step is very important. We're going to be adding the servo linkage to the body. This is made with a jumbo paper clip. You take your paper clip, and the first step is to face it up towards you. So it might be hard to see in the video, but the right side there is sticking straight up in the air. And then you want to take the left and the remainder of the paper clip and open it up and flatten it out straight. You only want about maybe ½ an inch going vertical there, and clip off the rest. Next, you want to go about 2 inches to your left, bend it at a 90 degree, but this is 90 degree going flat. The right side is going straight up towards your head. So there's different angles there. The next one, I do another 90 to the left. You need maybe ½ an inch is sufficient there with that little run in between. On the left side, about an inch is only needed, so you want to clip off the excess. Take the side that's facing straight up, stick it through one of the holes in the servo, and then bend it down like a fish hook. Or even a Christmas ornament, I guess. Alright, next you want to pop a hole through the back near the top, and then kind of make sure that everything moves freely. Once it's popped through, go ahead and bend that part that's sticking out flat with a cardboard. Now, something we didn't do here is actually you could tape the paper clip in place. It worked fine without, but if you really want to make sure it's secure, adding tape on both sides works well. Okay, the power bit's turned on, and as you can see, the Inchworm does move. Now, one thing you'll notice is it's not going anywhere. Now, it really doesn't do well on flat, smooth surfaces. Next, we're going to show you a demonstration on carpet, and it'll get up and move. But at this point, you can make adjustments to the servo linkage, make sure everything is moving freely, nothing's hitting, make sure everything's secure. And as you can see, now the Inchworm was placed on carpet and has a much different effect than on a smooth surface. Now, you can actually change the I-16 pulse bit and actually increase the speed, but if you go too fast and maximize it, it actually won't go anywhere. It goes too fast. Hope you found this tutorial helpful, and stay tuned for future Makerspace projects, and check out our site at Makerspaces.com for Makerspace and Maker education resources.